Hello, this is Physics Chapter 6, Work, Energy and Power. Lesson 4, Gravitational Potential Energy. Now, in this video, you will learn about gravitational potential energy and how work done is related to this GPE, gravitational potential energy. Now, at the end of this video, you should have learned and be able to answer the following 4 questions regarding gravitational potential energy. The first is this: what is gravitational potential energy? Symbol EP, capital E and a small p. What affects gravitational potential energy? Third, how to calculate gravitational potential energy? And the last, which is how is gravitational potential energy related to work done? So let's start our exploration here. Now, before we start to discuss more about gravitational potential energy, I would like to point out that there are 2 common forms of potential energy. The first one, which is the purpose of this video, is the gravitational potential energy, and it has something to do with this diagram. Okay, we are looking at the swimmer. She is standing on the platform above the pool. We are also going to deal with potential or gravitational potential energy when we talk about machines like this. This is a pile driver. Basically, what it does is that it is a mechanical hammer that is used to push pillars down into the ground. The second type of potential energy is elastic potential energy. So elastic potential energy is actually a kind of energy that is stored in objects which are elastic or stretchable, namely like springs and rubber bands. Okay. So, gravitational potential energy. Now, by definition, gravitational potential energy, symbol EP, is defined as the energy possessed by an object due to its position or height relative to the ground. What do we mean by relative here, you may ask? Relative simply means the object's height or position from the ground. Okay? The SI unit of GPE is none other than joules, the symbol of which is a capital J. Now, in this slide, let us try to understand a little bit more about GPE, or gravitational potential energy. We are going to do this by asking ourselves a few questions and referring to the diagram on the right hand side. Now, on this diagram, we see a man trying to lift a rock or a stone of certain mass m. Okay? Originally, the rock is on the ground. So, before he lifted it up to a height h, let's ask ourselves this question then. What is the EP or GPE of the rock on the ground? If you recall the definition of gravitational potential energy, that it is the energy of an object depending on its height above ground. Since this stone or rock is on the ground and therefore the height above ground is 0, the GPE of this rock on the ground would therefore be 0. So we see that height actually affects the amount of GPE. So let's say in this next situation, the man actually lifts this stone or the rock up to this height h, which is level to his head. Okay, so the question to ask is this: what happens to the GPE of this rock if this man were to lift it up even further? Well, as you could have, we would have guessed, since the position of the rock, if it's above his head, is higher than its original height h, the GPE of this rock above his head would be more than the GPE at this location. Again, this emphasizes that with greater height, we have a higher GPE. Now, let's then ask ourselves, what happens if this man were actually to lift a rock or a stone with a smaller mass? Okay, maybe a smaller rock. So if this person were to lift a rock with a smaller mass to the same height, how would be the EP or the GPE of this rock be compared to lifting a rock of a greater mass? If you are thinking, well, if it's a rock with a smaller mass, therefore the GPE is smaller or lower, then you're right. So we see from here that the mass of the object that is being lifted also affects the amount of gravitational potential energy that it has. Now, the last question is this: What happens if this particular person were to repeat the same experiment, which is to leave a rock or a stone with a mass m to the same height here? Instead of on the Earth, he repeats this on the Moon. Well, if you are thinking that, hey, if that's the situation, same mass, same height, but it's on the Moon whereby the gravity is less, and if you are thinking that this will actually reduce the gravitational potential energy of this rock compared to that on Earth, then you're right. Okay, so the gravitational field strength of a particular place do actually affects the GPE of an object. So that brings us to this next slide. From the previous slide, what have you learned about what are the factors that affects gravitational potential energy? And it's these three things that we have been discussing. First, the mass of the object, small m. Second, gravitational field strength of that particular location, symbol small g. And the third will be the height of the object from ground, small h. So from here, we can actually calculate the amount of GPE of an object. Okay, so to calculate that, we will actually have to use this particular formula. EP, which is used to represent gravitational potential energy, can be simply calculated by taking the mass of the object, multiply the gravitational field strength of that location, and multiply h, the height of which the object is raised above ground. Okay, so do take note, small m, which represent mass, has to be in kilogram for this formula to work. G, or small g, represents gravitational field strength stated in terms of Newton per kilogram. And h, small h, representing the height of the object from ground, has to be in the unit meters. Not centimeters, not kilometers, but meters. And just to recap, the SI unit of GPE is none other than the joules. Now let's have a look at this example. Okay, this diagram shows a coconut tree with a coconut right at the top. Okay, this coconut before falling is 6 meters above the ground, and the mass of the coconut is found to be 2 kilograms. For the part A, you are required to calculate its gravitational potential energy before it falls. So if that's the case, it's very simple. We just call out the formula and recall that to be EP equals to mgh, and substituting the mass into the equation or the formula, g on Earth is, if you recall, it is 10, and h, the height of the coconut above ground, is 6 meters. Multiplying all of this together, we get 120 joules. The next question is this: what is the gravitational potential energy of the coconut when it is halfway, when it has fallen and it is halfway down, okay, at this position, 3 meters away? Well, since the height of this coconut is just 3 meters above ground, this would therefore suggest that the GPE would also be less. So how much less? Well, since the mass of the coconut remains the same, Earth's gravity remains at 10 in this location, and since the height is now 3 meters, by substituting into this equation, that will give us the answer of 60 joules. Last question: what would be the EP of the coconut when it's on the ground? Well, since it's on the ground, the height of this coconut above ground is 0, and therefore the potential energy of this coconut would be 0 joules on the ground. Alright, so let's look at how we can relate potential energy or gravitational potential energy to work done. So referring back to the same diagram, let's look at it in terms of work done. Obviously, for this person to raise a stone to this height h, he would have to exert some force. Okay, so by using some lift force, he's able to move the rock a distance h along the same direction as the direction of the force. Alright, so in other words, when he does work to raise the rock by itself, or the stone itself, gains GPE. So assuming that the work done by the person is 50 joules to lift the rock up to this height, then what would be the gain in GPE of the rock? Well, if you are thinking 50 joules, then you are right. Okay, the amount of work done by this person actually is the same as the gain in the gravitational potential energy of the rock at this same position. And so that brings us to the very last slide of this video. We are just going to summarize what is gravitational potential energy. Okay, so what is gravitational potential energy, or symbol EP? It is simply the energy of an object above ground. How do we then calculate the GPE? The formula that we use is mgh, where m stands for mass, g the gravity of the earth or gravitational field strength, and h represents the height of the object above ground. Recall as well, m, mass has to be in kilogram, gravitational field strength of earth has to be in Newton per kilogram, and lastly, height of the object has to be in meters. And the last question is this: what affects gravitational potential energy of an object? Well, three things. First, that would be the mass. Second would be the gravitational field strength. And last would be the height of the object above ground. Okay? So with that, that brings us to the end of this video. Thank you for listening.